So sketching parabolas in the form of ax squared plus bx plus c. You cannot sketch your graph in this form. If you do, I'll be very impressed, but it would be very difficult. You're going to have to find a way to factorize it first, and that's why we went through it in the last chapter. Now, more often than not, you're going to choose completing the square because it'll get you turning point form. It's the point of completing the square. That's why we like it. It gets us turning point form. Now, when you're finding the turning point, which can help you find the turning point form if you need it, to find the turning point, you can use three methods. You can find the midpoint between the two x-intercepts. So that turning point is going to be directly in the middle of your two x-intercepts. So if you have your intercepts, you can find the turning point or the x-coordinate of the turning point by finding the midway point between the two x-intercepts. You can also use this formula here, negative b over 2a. Now, you get the b and a from your general equation. So whatever a is there, whatever b is there, that's where you're getting your a and b from. Now, your third step, which is what we'll also be looking at today, is completing the square and getting your turning point that way. So, our first example, I'm guessing this shouldn't look new to you because we did do it in chapter 7 when you factorized and solved. So, this is a quadratic that's been factorized. What information can I get from this factorized form? I know it was a while ago, getting the gears turning. Can I get my x solutions, my x-intercepts? By using the null factor law, I'm fully expecting my class to know that. So, for those that need to catch up, we can use the null factor law to solve this. Null factor law tells us that if I make either one of those brackets equal to 0, I can solve x using that. Because if 1 equals 0, then the whole equation is going to equal 0. So, I split these up. And I'm going to make x minus 3 equal to 0. And I'm going to make x plus 2 equal to 0. And I'm going to solve each of them. So in this case, x equals 3. And in this case over here, x is equal to negative 2. So what are these two x solutions now? Fantastic, they're my x-intercepts. So I'm going to go ahead and sketch this graph. Sorry, just give me a moment. Now I'm going to draw a graph because I'm going to sketch my solutions onto an axis. So my axis, got the y and the x. Okay, so I'm going to put in the positive 3, the negative 2, and then I'm going to draw a very wide, now thinking about it, parabola. Okay, now remember, when you're sketching graphs, it's really important to include the x-intercepts, the y-intercept, and the turning point. They are a must from now on. When it says sketch, those are implied. It's not going to say sketch the graph with x-intercepts, y-intercepts, and turning point. That's implied. Marks will be allocated for each of those. So if there's 5 marks allocated to a graph, you know that they're expected. Okay, don't tell me you're surprised when you get your mark back. So I can find my turning point using the first step that I outlined up here, which was finding the midpoint between the two x-intercepts. So I know my two x-intercepts. How do I find halfway point? Fantastic. So to find the x-coordinate of the turning point, and I'm going to use TP for turning point, you're going to add them together. So negative 2 plus 3, so whatever your x-intercepts are, add them together and divide by 2. It's exactly the same process as taking the average. So negative 2 plus 3 is 1 over 2. So my turning point, my x-coordinate, is a half. How do you think I now find the y-coordinate of my turning point? Yes, good. I heard someone whisper it over there. Substitute. I'm now going to substitute that half into my equation that I've got up here. So to find the y turning point, substitute x. So I've got y is equal to x minus 3 and x plus 2. I'm going to substitute a half where x is. and solve. So a half minus 3 is negative 2.5, and a half plus 2 is 2.5. Now negative 2.5 times 2.5, can someone quickly check that in the CAS for me? My brain's working a bit slow. Or Josh, if you got it. Great, thank you. Fantastic. So I've got my turning point coordinate now. A great way to check yourself when you're doing this, say for example I'd ended up with a positive value. I could have looked at where my turning point was supposed to be and seen I am in the negative zone of y, but I've got a positive value. That's how you'll know you'll have to go back. So if your value that you've calculated does not match up with your graph that you know you need to have, go back. Don't give me a positive value when it's clearly in the negative. Okay, that's the lesson here. Okay, last step, we need to find the y-intercept. Just to practice, what do I make x equal when I'm finding the y-intercept? 0, fantastic. So x equals 0, so I'm going to have 0 minus 3 and 0 minus 2 plus 2. So y is equal to negative 3 times 2, so I'm going to get my y-intercept at negative 6. That's all your points there. Okay, coming down to here, I'm sketching the graph of 2x squared minus 6x minus 6. Now, that's in general form. I can't sketch it from that. I'm going to need to factorize. I'm going to give you all 2 minutes to factorize that for me. Square. Now, as I said before, it cannot be it must be monic. It cannot have that number 2. So I'm going to factor out the 2 first. So I'm going to divide all these numbers by 2, and I end up with that. Now, for the majority of the process, the 2 stays on the outside. Now, I'm very focused on that number 3 there. Remember, that 3 is the key number. Whatever the B number is the number you're focusing on. So I have x squared minus 3x. That hasn't disappeared yet. Then plus comes first. 3 over 2 squared minus the same thing, minus 3. Now, these first 3 terms make a perfect square. So we have looked at perfect squares before. That's what we're sort of forcing the equation to become. We're forcing a perfect square. So 2 stays on the outside. 2 stays on the outside. Then inside, I'm creating a new bracket for my perfect square. I'm factorizing the perfect square back into a bracket. So the x comes down. The minus comes from here. So if that's a plus there, you're going to have a plus in the bracket. I have a minus, so I'm taking the minus down. And then the other number comes from inside the bracket. So I don't expand the squared for the first one because I just want the number inside the bracket. So I've got 3 over 2, so I'm going to keep that as 3 over 2. I'm not going to bother squaring it, making it 9 over 4, and then square rooting it back again. There's no point. I'm going to keep it as 3 over 2 and put it in the bracket. Then this bracket gets squared, and then I work with my other numbers on the outside. So this 3 over 2 becomes 9 over 4, remembering back to our indices where we square the top and the bottom, and then minus 3. Close the bracket because I've still got the 2 on the outside. So just quickly, I'm going to do, let's write this again. So I've got x minus 3 over 2 squared. Now, remember to plus and add fractions, you need the same denominator. So 9 over 4, and then 3 as a denominator of 4 is going to be 12 over 4. So now I'm going to get 21 over 4 as my fraction. Now, you're not actually done here. You have one more step. that 2 doesn't stay on the outside. You need to multiply it back in. So when you multiply the 2 back into your big bracket that you've now got, it can stay outside this bracket, but what it'll multiply by 2 is your 21 over 4, which is going to be 42 over 4, but I'm just going to cancel them by a factor of 2 and make it 21 over 2. Okay, so that is your squared bracket. That's your turning point bracket. Can we just confirm with people on the calculator that I did that correctly? Yeah. Okay, great. So this is now in turning point form. Someone tell me my turning point that I can gather from my completed square. Alex. Perfect. Okay, so remember I said last time that number in the bracket is the x-coordinate, but you're taking it with the opposite sign. So it's a minus in that bracket, so when I take it for the turning point, it's a positive, but the y stays the same. So that y is negative 21 over 2, so my turning point is also negative 21 over 2. Okay, so before I mentioned as well, sorry for the people that are writing down, I'm just going to scroll up for a sec, that we can also use the formula negative b over 2a to find the turning point, and I'm going to confirm that for you now that we've found it with completing the square. So to find the turning point, we can also use negative b over 2a, and that comes from our general equation before we factorised it. As I said, these are 2 different options for you. So a is obviously the 2, and b is negative 6. This is to find the x-coordinate, by the way. So substituting those in. Sorry, I can't even remember what I'm aiming for. 3 over 2. So I've got minus, then my b is the negative 6, and then on the bottom I've got 2 times a, which my a is 2. So I'm going to end up with 6 over 4, which can be cancelled down to 3 over 2, which is exactly what I got when I completed the square. So it doesn't actually matter which one you use. Personally, I like to put the effort in to complete the square because it gives you the y coordinate straight away, whereas now I've only got the x and I've got to substitute it back in, which I'm not going to substitute that for you. I'm fully expecting that you know how to substitute at this point. And I've got those there. Now that you've got those, you're going to sketch, chuck them on a graph. How would I find the x-coordinates now, the x-intercepts? Because the turning point doesn't give me those. If I need to find the x-coordinate, what am I doing? Solving or factorising? Solving, fantastic. Now, can I use the null factor law in this situation? Do I have 2 brackets? No, I don't have 2 brackets, so I can't use the null factor law, which means I'm going straight to the quadratic formula. Which I'll write down because I'm not expecting anybody to remember it. So negative b plus or minus the square root of b squared minus 4ac over 2a makes up your entire quadratic formula. Please don't forget about that 2a on the bottom. Someone did do that to me in the exam. Devastating mistake. Okay, so the a, b, c come from that general equation. So the a is 2, b is negative 6, and so is c. And I'm just going to substitute them in. If someone can put this in a calculator while I'm writing it down, that would be fabulous.